Hi, so I'm Chris. I'm a software engineer at Puppet. Been working there for about 3 years now, and for the last several months, the project I've been working on is called Puppet Server, so I'm here to talk to you guys about that a little bit today. Before I get started, just so I know how much time to spend on certain things in the talk, how many of you guys have been by the demo area and seen the metrics demo with the graphite and Grafana stuff? Okay, good chunk of you. And how many of you saw Luke's keynote where we demoed a little bit of that stuff as well? Okay, almost everyone. All right, I probably won't spend too much time on that part then. Cool. Oh, and one other question, just out of curiosity. How many of you use graphite at your place of work or are familiar with it? Okay, cool. All right, so what's this Puppet server thing? So I'm going to talk a little bit today about kind of some of the lower level architecture of the new server and why we made some of the choices. Hopefully, if we've done our job well, this will just be interesting to you, but it won't be something that necessarily affects you as a user. If you really have to know too much about like the fact that we chose Clojure as the language to write this in, that probably means that I did something wrong. And so at the end of the talk, I'll have my contact info up there so you can yell at me and let us know where we've exposed that stuff too much. Because our goal right now is to make sure this is as seamless of a drop-in replacement for the existing Puppet Master as possible. Okay, so Puppet Server is a new open source project. We just open sourced it at the beginning of the conference on Monday. As I mentioned, it's kind of a drop-in replacement for the existing Puppet Master. And more specifically, it's really about kind of being an alternative to the web server functionality in the existing master. So something you'd use instead of the WebRick and Apache passenger options for running the Puppet Master. It's written in Clojure. It has an embedded Jetty web server in it, and it uses JRuby to still allow us to run some of the Ruby code. So why did we decide to do this? So it has a lot to do with, basically, there's been some pretty drastic changes in the landscape of configuration management over the last 5 years, and specifically like the last 2 or 3 years. We've seen a drastic uptake in virtualization and cloud computing. These are becoming things that are almost ubiquitous in IT shops, which leads to the phenomenon that the metaphor that you've probably heard a million times at this conference already, the whole pets versus cattle thing. When you have a very small number of nodes, you probably know them all by name. You know how their day's been going, what they had for dinner last night. You definitely will know if something is going wrong on one of them. But as you start to get into a more virtualized environment and manage larger and larger numbers of nodes, it's just not feasible to have that intimate of a relationship with any of them. And it becomes more of managing a herd of nodes that hopefully look pretty similar to one another, but not necessarily wanting to have to deal with them on an individual basis. So obviously, a side effect of this is that Puppet users have more and larger numbers of nodes that they want to be able to manage with Puppet. So that's led us to focus more and more of our attention on performance, scaling, availability. The more agents you try to connect to your master, the more load it puts on that server, and then we have to start to figure out solutions when we get to the maximum capacity that a single machine can handle. So with that in mind, we've been working on new designs for our server-side architecture, both for some of our existing products, but also for our new projects that we're starting up and new features that we have going forward. So you can kind of think of Puppet Server as the next step in the evolution of the Puppet Master towards improvements in all of these areas. So before we get into some of the architecture stuff, I'll just share a couple of numbers. We've been doing a lot of performance testing because, as I mentioned, making sure that we're improving performance is a huge goal of this project. So we've been collecting data, and what we've basically been doing is comparing the stack that we shipped in Puppet Enterprise 3.3, which is Apache and Passenger and Puppet 3.6.2, with the new stack that we'll be shipping in the upcoming Puppet Enterprise 3.4 release. And so that stack is Puppet Server with the newer version of Puppet 3.7.0. And so the tests that we've been running, we've been generally simulating about 1,000 nodes of load on the server. And it's pretty low-end server hardware that we're testing against. So a big fancy high-end server could handle a lot more load than what these tests are targeting. But this is some of the numbers we're seeing. The average request response time, so this is out of all the HTTP requests that the agents are making to the master, what's the average amount of time it takes the master to handle the request. And what we've seen is between the old stack and the new stack, we've dropped from maybe 80 milliseconds all the way down to like 25 milliseconds. So that's a pretty huge win. Catalog compilation is usually the particular request that the agents are making to the masters that folks are the most interested in, because it's generally the most expensive one. It's also the one you have the most control over because it's affected by how you write your Puppet code. So it's not quite as stark of an improvement on that one. We've dropped from maybe 1,400 milliseconds to about 1,000 or a second, I guess. But so it's not quite as stark of a difference as the overall request response time, but it's still a pretty notable improvement. And on this graph, what we're looking at is the previous two graphs are metrics that we're collecting from the server side, like showing the performance of things we're observing on the server. This one's more about the perspective of the agent. So from an agent's point of view, from the point in time that I make my first request of the agent run to the master, to the time that I've completed my final request of that agent run. And we've been seeing that drop as much as from like 9 seconds all the way down to like 2.5 seconds. And this is partially due to Puppet server, partially also due to just improvements we've made in the Puppet code itself in between Puppet 3.6 and Puppet 3.7. So a side effect of improving the performance on the master is that you'll be able to handle more agents for any individual Puppet master. As the request response times get lower, that means the master has more CPU cycles available to handle more requests, so you can add more agents to its load. So to illustrate that, as I mentioned before, all those previous numbers that I was showing were when we were using a load of about 1,000 agents. So we doubled that up to about 2,000 agents, and you can see there's like a really drastic difference here. On the old stack, it's very clear that jumping from 1,000 agents to 2,000 agents was well past the capabilities of what this server could handle, and so we saw the agent runtime spike up to like 60 seconds because requests were being stuck in the queue for so long before they got responses. And on the new stack, on my previous slide, I said that on the new stack, the agent runtime was showing up as like 2.5 seconds. Here, it's about 4 seconds. So it definitely made a difference to increase the load from 1,000 to 2,000 agents, but it's not. It's obviously we haven't pushed it past its tipping point yet, like we did with the old stack. So that's pretty encouraging. And one of the reasons that I'm even more excited about these numbers is that we still have a ton of tuning to do. Up until this point in time, we've been really focusing on our main focuses on Puppet server have been on correctness, backwards compatibility, stability. We want to make sure that like everything works first, right? We haven't even really gotten to the phase where we started trying to optimize things very much. And I mentioned earlier that we're using JRuby to run some Ruby code in there, and I'll talk about that more later. But one thing that's pretty cool is as we bump to new versions of JRuby, as they do new releases, we've been seeing as much as 10 or 15% performance improvements just from bumping up to the next version of JRuby, because those guys are always optimizing their stuff. So I actually have some newer builds that are newer than the ones that I took those numbers from that are showing like even better performance than that. So it's pretty cool. Also, JRuby exposes a ton of optimization settings. You can set it to try to like, kind of pre-compile some of the Ruby code that it's going to run for the purposes of optimization. We have all that stuff just completely turned off right now. Like I said, we're focusing on being really conservative and making sure we get everything working right first. So when we get some time to start tuning those a little bit, we might be able to even squeeze a little more out there. So it's looking good. So now a little bit more about the architecture. So as we've sort of started focusing more and more on performance and scalability, we felt like the product that we at Puppet Labs have had the most success with that kind of thing on is PuppetDB. It's definitely been the best performing application that we've written to date. So, we wanted to make sure we were taking advantage of the lessons we've learned there and the success that we've had with that product. So that was a lot of the inspiration for some of the tech choices that we made for Puppet Server. So Clojure as the implementation language, the embedded Jetty web server, and our Trapper Keeper application framework, those are all things that we brought over from PuppetDB. And then we've also added JRuby to the mix. So the runtime underlying all of these technologies, obviously, is the JVM. So I wanted to talk a little bit about why we're moving certain things over to the JVM. And I was starting to work on a slide for this, but then I realized that Deepak already had a slide for this at his talk last year, and it would be much easier for me to just steal his, so I did that. And look how pumped up he looks about it, too. So in a runtime for our server-side code, this is not for our client-side code, just for our server-side code. Some of the stuff we're looking for is we want something that's fast, we want something that's free, we want something that's really portable because we support a lot of different operating systems for our server-side stack. We need something that makes it really easy to take advantage of multiple cores in a system. And we need something that's really popular and has a lot of existing libraries and code and has been really well battle tested. And so the JVM is just a really good fit for us for all of those goals. So those are some of the things that have led us in that direction. Some other goals that we had specifically for this project are we'd like to have more control over everything that's going on in the system from the time that a request comes in from the agent all the way through to the time that we're finished handling that request. We'd like to have the ability to examine the state of everything that's going on in the entire application and do intelligent things based on that information. So coordinate other things that we might be doing inside the application based on what's going on elsewhere. And then we also wanted to be really cognizant of not reinventing wheels. Like, we don't need to write our own web server. That obviously sounds like a pretty obvious statement to most of you, but believe it or not, I've actually worked at places that did not seem to be as obvious to them. So we're trying to be really cognizant of that. And that sort of led me to like a general theme that I feel is emerging for some of our server-side stuff is moving away from building our products on top of open source applications and moving towards building our products on top of open source libraries. So there's already plenty of open source work out there that accomplishes tons of the functionality that we need. But if we can find libraries to use instead of applications in certain cases, it just gives us a lot more control over how the system's running from end to end. And I'll dive into a few diagrams that hopefully will help illustrate that a little bit further. So this is kind of a rough representation of what our deployment model looks like when we're running under the Apache and Passenger stack. So on the left, you've got all of the Puppet agents making their HTTP requests up to the master. So Apache receives those. Apache is configured to use Passenger to handle them. Passenger is configured to spawn off some number of Ruby sub-processes. And then those processes are what actually loads up the Puppet master Ruby code, which eventually ends up handling the requests, right? So you'll notice that what I tried to do with this slide is the purple things on the slide are kind of trying to highlight the code that we wrote, that we own, that we have control over. And you'll notice that there's this kind of big gap in the middle here where it's a lot of code that we don't have any control over. So there's configuration settings we can set to tune Apache and Passenger, but once we've tinkered with those and started the process up, that's the end of our influence over that. So the requests come in, and Apache does what it wants to do with them. Passenger does what it wants to do with them. We lose control over that entire middle area, which works fine for many things. But when we start trying to get into some more advanced feature sets, it doesn't have some of those properties that I described before about letting us be able to really easily examine and coordinate the state of the entire system as a whole. So this slide is kind of a rough example of what the new architecture looks like with Puppet Server. So on the left-hand side, everything's the same agents, not modified at all. All your existing extensions still work there. On the right-hand side, we're still using most of the Puppet master Ruby code, unmodified from how we've used it before, so everything's pretty much the same over there. But in the middle, we now have this box that is entirely in purple, where we have an embedded Jetty web server instead of Apache. And that gives us the ability to control, exactly how we launch it, exactly what it's doing as it runs. And so then there's a pool of threads that are used to handle requests, and each of those threads will call directly into our Clojure code. And then from there, what we do is we have a pool of JRuby interpreters. So these are, you can almost think of these as like little Ruby virtual machines that we instantiate in our code. But because we have control over this whole container, we can do really interesting things with those. We can quarantine different JRuby instances so that they're only available to handle certain kinds of requests, which would allow us to potentially load different Ruby code in one versus the other. We're not quite taking advantage of all of that functionality yet, but it was a big part of our thinking for moving forward. So it'll let us do things like separate environments, like Puppet environments, a lot more cleanly than how they're separated now. Another thing that this allows us to do is we can start extending the server by dropping new bits of functionality into the same container. And the new things that we introduce can run on little worker threads that don't interfere with anything else that's going on in the system, but they have access to all of the state that's going on elsewhere in the system, so we can introspect things and coordinate actions between different subsystems. So the first concrete example that we have that takes advantage of that is in the new version of Puppet Enterprise that'll be coming out later this year, we have a new metrics service. And it's basically a little background thread that runs inside of this container, and it collects metrics from all the different parts of the system. So it collects metrics about how many requests Jetty is actively processing, what types of requests they are, how long they're taking to be handled. But it can also see into the JRuby pool and determine how many of the JRuby instances are in use, what they're doing, how it can even get some visibility into what's going on inside of the Ruby code that's going on that's being executed in those JRuby interpreters. And this is what we've been demoing a lot over at the demo area. It seemed like most of you guys have probably already seen some of that, so I'm not going to show the demo today. If you haven't seen it and you're interested in it, you can head over to the demo area after this, and they're still showing it over there. But the metrics service has some configuration options that allow you to say, cool, you're collecting all this data about what's going on in my system. I want to be able to see it from outside the server, and you can choose where you want it to send the data to. So right now, there are two places that we allow you to turn on in configuration to send the data to. There's JMX, which is basically just in the memory of the process itself, but there are tons of external tools that you can use to both GUI and command line tools that you can use to query the values of all those metrics that are stored in JMX. We also allow you to send that data over to Graphite. And if you send it over to Graphite, things start to get a lot more interesting, because Graphite will store historical data for however long you've configured it to do that. And there's all kinds of cool third-party extensions to Graphite that are like basically little simple web UIs that allow you to build up dashboards that show exactly the set of metrics that you care about, that it's just pulling from your Graphite server. So, and this screenshot here is from one of those third-party tools. It's called Grafana, which was just, it was the dashboard that we started playing around with that had the coolest looking and most flexible UI, so that's why we chose that. But another thing that's really cool about Grafana is once you've kind of tweaked your graphs and picked out which metrics you're interested in, you can save it, and then you can export that dashboard as a JSON file, and you can just copy it around to other machines or email it to your coworker or whatever, and then they can just import it into their browser, and they'll be able to see the exact same dashboard that you were looking at. So what we're planning on doing for the PE 3.4 release is publishing a little bit of documentation about how you can use a Puppet module to help you get Graphite and Grafana set up if you don't already have them set up. And then we're going to put this JSON file up somewhere so that people can grab it and download it and use it as like a starting point to play around with. Really, really interested in getting feedback from people about that, because this is kind of just like our first stab of what we think some of the most interesting ways to look at these metrics will be. But I have every expectation that you guys are going to be able to find much cooler ways to represent this data than what we found so far. So Really looking forward to getting feedback on that. So I talked about the metric service as being sort of our first major extension of Puppet Server to take advantage of some of the new capabilities that we have in this architecture. So I wanted to also talk really quickly about some other ones that we are thinking about for the future. So now that we have these threads that we can run in the background to use as extension points, we're going to be able to start doing things like scheduling. The product design certainly hasn't gotten very far on this yet, so I don't know exactly what it's going to end up looking like. But we now have the ability, at least, to like write extensions that schedule tasks to run at certain intervals or at certain specific times, and do things asynchronously without interfering with the rest of what's going on inside of the Puppet server. And the other thing about extensions that I wanted to make sure to mention is that we still love Ruby. And we know that there's tons of folks in the community that still love Ruby. It's a really good fit for a lot of the extension points that Puppet offers. And a lot of times when we talk to folks about the fact that we're starting to move some of our server stuff over to Clojure, they ask, they want to make sure that we actually still intend to support the existing Ruby extension points. And the answer to that is definitely yes. Ruby's not going anywhere. The server-side Ruby extension points will be running in JRuby now. The agent-side Ruby extension points are totally unchanged because the agent architecture hasn't changed as part of this. Okay, so now I'll talk a little bit more about Trapper Keeper, which is our Clojure application framework. It's a project that we open sourced maybe 6 months ago, maybe a little bit longer than that. It's a really tiny little piece of code. It doesn't really do all that much, but it gives us a path forward to doing some more interesting things in the realm of service-oriented architecture. So this is kind of a rough example of what the current Puppet server might look like from the inside. So you've got this container, and at the very bottom of it, at the very bottom, we've got our tiny little Trapper Keeper framework, whose job it is really only to allow you to turn individual other services that might be running in this container on and off. That's really all it's there for. So you've got the embedded Jetty web server. You've got our new certificate authority service, which is like the first service that we actually ported over to Clojure from the existing Ruby code base. You've got the metric service that I mentioned. You've got a service that acts as like a pool, like a handler, a container for all the JRuby instances that we fire up, so other services can ask it for a JRuby instance when they need one. And then right now you've got this kind of larger, like more monolithic Puppet master service that's running in the container. So this is the one that still handles most of the work of what we're doing on the server, and it handles it, as I mentioned before, by pretty much just by calling into the existing Ruby code that everyone's been using for years, right? So with this architecture, we can start to do things like this, where we take that package and we install it on 3 different servers, and because we want to have more than one Puppet master, right? And so we'll have we could, for example, have 2 Puppet masters up front that were sort of the main worker Puppet masters that all the agents are talking to. And those 2 might have their certificate authority service turned off because they want to use a central 3rd master for the certificate authority. And that's what this one on the bottom here is. That one's going to serve as our certificate authority service. So it has that service still enabled, but it is now able to turn off both the JRuby interpreter pool service and the Puppet master service, which has the side effect of meaning that for that node, there's a lot fewer hardware requirements. So the JRuby interpreter pool is probably the most memory intensive part of the application. So being able to switch that off means like you don't need nearly as much RAM to run that server as you would on the other 2. And this model is not very different at all from how we help our customers scale out the Puppet master today. Like this is basically how our professional services team scales the existing master today. But the difference is we're actually changing the internals of the design of the system to be more specifically tailored to that rather than having to kind of dance around it and hack on things to make it work. And it's a step forward towards what we want to do in the next couple of releases, which is we want to break up that master service from that big monolithic thing that I had on the previous slide into a set of smaller, more modular, more composable services. So in this diagram, I've broken the master up into 4 smaller services. There's the node service, the catalog compiler service, the file server, and the report service. And so just arbitrarily in this example, I turned off the file server and the report server on one of them and turned off the node and catalog on the other one, which would mean that all the catalog compilation work happened on that master on the left and all the file serving happened on this one on the right. And again, you can imagine that that gives you more control over what you choose to use for your hardware for each of these things. So like on the file server master, you might want to have a much more expensive, faster disk to make those file requests get handled more quickly. And on the compiler master, you're going to want like a beefier CPU with more cores because the catalog compilation is really CPU intensive. So we'll be collecting more metrics and like hopefully be able to give people recommendations on how their hardware choices are going to be impacted by this stuff. But the general idea is the more fine-grained we can make these services, the more control you'll have over like what tasks are actually happening on a specific piece of hardware. But for simple installations, everything's still packaged together in one nice, neat package. And if you just need to run something in a dev environment or you're just getting started and you don't have a ton of nodes and one server is sufficient for you, it's still really easy to just drop it down and leave them all turned on and have everything work on one node. So, wrapping things up a little. So Puppet server is fast. We're really happy about the performance numbers that we've been getting in our tests so far. I'll have some time for questions in just a few seconds here. We're optimistic that it's going to get even faster as we move forward. And as we move more and more towards service-oriented architecture patterns, we expect everything to get easier and easier to scale. We have a whole lot more features planned that are really going to be enabled by our switch to this technology stack. So we're really looking forward to some of that. As I mentioned, there's a preview release that we've open sourced and already put into our Puppet Labs package repository. So if folks can try it out today. We would really love for people to do that and send us your feedback. We tried very hard to make sure that it's, as I mentioned before, a drop-in, backwards compatible replacement for your existing masters. So if you have a test box somewhere, you already got an Apache Passenger setup going on, you can literally just install this package, shut down your HTTPD service, start up the new service, and it should just pick up all your config and everything, and it should just work. And if it doesn't for some reason, you should just be able to switch the new service off, switch your HTTPD back on, and you'll be back over in your existing environment. It's definitely new enough we don't consider it production ready yet, so don't go throw it out on your big server that's managing 10,000 nodes. But for test environments, it's definitely something we think is ready for people to play with and start giving us feedback on. So we hope you'll do that because your feedback really helps us make sure we're targeting the right stuff for upcoming releases. Just a few quick shout outs and then I'll take some questions if folks have them. I wanted to thank a couple of open source projects that have been really helpful to us, starting with JRuby. I've been continually impressed with how seamless the integration with JRuby has been. I sort of expected there might be some quirky incompatibilities with how they support like Ruby 1.9 interpretation versus the real Ruby. But it's been really seamless. It's been a lot faster than I could have even hoped for. And the devs on that project are really responsive. They've helped us fix a few bugs and just been really helpful to us. So highly recommend that project if it's something that fits into your workflow anywhere. Another one is Gatling, which is a load test tool. Allows you to record some HTTP traffic that's going between a client and a master, and then a client and a server, which in our case is the agent and the master, and then replay that with varying amounts of load. And it's incredibly efficient. It can generate more load from like a laptop than I've ever seen any other tool be able to generate before. So it's really cool, and it generates amazing like graphs and statistics about how everything went. So it's really cool. check it out, very useful. And then a few folks at Puppet Labs, I want to thank our QA and QE teams because they're just awesome at helping us test all this stuff. Our release engineering team, this picture isn't actually from our office, but when I Googled for images for the phrase release engineering, it came up, and it didn't seem entirely inappropriate, so I used it. And then to my team who's helped me do the development work on this project over the last several months. Really grateful for all the hard work they've put in. And that's it for me. This is some info about where the GitHub repo is, what the name of the package is if you want to pull it down from our package repositories. We have some minimal docs in the GitHub repo so far. If you look at the README, we've got some step-by-step instructions for installing from package or running from source if you're interested in hacking on the code. And then that's my contact info if anyone wants to either praise or berate me for anything. I welcome all feedback. And so now I can take some questions if anyone has any.
So I wasn't clear where Ruby ends and the Clojure begins. So like, is there going to be a time when, well, is the Ruby server code just run as like interpreted, or is it like a separate development track where, like, because can you run WebRick with the same code as you can run in the JVM?
Right now, that is the case, yes. The hope is that, that this will become an appealing enough option that shows enough improvement over the existing web servers that folks have been using that we will probably make this the default and sort of phase out some of our support for WebRick and Apache and Passenger. But right now, they're absolutely the same. You can run them side by side. You can switch back and forth between them as you see fit.
With the JMX and the Graphite, I'm actually pulling JMX data and dumping it into Graphite. Is that what it's doing on that? Or is there something fancier?
No, so the question was, he said he was used to pulling JMX data, I guess basically kind of manually, writing your own tools to pull the JMX data and ship it over to the Graphite server. And he's asking if that's what we're doing behind the scenes. The answer to that is no. We actually, the metric service is actually collecting all the data in memory. There's some libraries out there that we're using for that. And the collection is kind of like one piece of it, and then there's a separate reporting piece that you can like turn on different reporters. And one of those reporters will send the data to JMX, and the other one will send it directly over the wire to Graphite. So you can enable the Graphite one without enabling the JMX one if you want, and the data will still get over to Graphite.
It's the same data?
Same exact data, yeah. And we fully expect to add more reporters to that list over time. So we know we're going to add Ganglia pretty soon. And we've had a lot of questions at this conference about adding support for Elasticsearch and the Logstash stack, which is something I haven't quite looked into as much yet, but we're definitely going to look into it, and hopefully that won't be too hard to do. And that reminded me of another thing I wanted to mention. The metric stuff is, I almost am kind of thinking of this as like a preview release of the metric stuff, because this is just like the first big chunk of metrics that we thought were interesting. But there's way more stuff that we can capture in there. Like we've had some people asking about like whether we can capture counts of different types of resources that are being used in your system, or different classes or modules, and maybe how expensive those different things are. And so we're definitely going to start playing around with that, and I think we can pull that off pretty easily. But if you start messing around with any of the metric stuff and you have any suggestions at all about additional metrics that you think would be valuable, like, let us know, and we can probably add them. The system is really easy to extend at this point. So, any other questions? Yeah.
Is that using the CodaHail metrics?
It is, yes. The question was, is it using the CodaHail metrics library? And the answer is yes.
So I have some Puppet nodes that are a lot of resources on them, and a big bottleneck for me is Python serialization. So does this improve that at all?
So the question was that, I guess there was a statement at the beginning, which is that Python serialization tends to be a performance bottleneck for systems that have a lot of resources on them. And the question was, does this product address that problem? And the answer is no, not as such. I mean, I think there are some overall throughput improvements just from the whole change in architecture, but it doesn't address Python specifically. However, I have been talking to some of my coworkers, one of whom you're sitting a few chairs down from, about the possibility of revamping that for Puppet 4, and we're talking about that a lot right now. Most of us, at least on the engineering side, would really like to just get rid of PSON altogether and solve the problem that it was originally intended to address in a more elegant and standard compliant way. But we feel like we kind of need to do that on a major version boundary of Puppet. We don't want to risk breaking things in a minor release. So if that happens, it'll probably happen on the 4.0 boundary. So no promises yet, but we're definitely looking into that. Any other questions? Yeah.
Have you looked into tuning, JVM tuning notes, heap size, garbage collector, all the typical handles that people do for JVM?
We have not spent as much time on that yet as we would like to. It's in our plans for sure. Again, like so far, the focus has been more on just getting everything stable and correct, and we'll move into more of an optimization phase soon here. We do have, when we build our packages, like our RPMs and our debs of this stuff, we do lay down a set of default JVM arguments, and so hopefully we'll, as we figure out, garbage collector optimizations and stuff that we think people will want, we'll just add them to that list so that they get set that way when your package is installed, and you hopefully don't have to think about that stuff too much yourself. That's the goal. Yep, back there.
I've heard a lot about Puppet Enterprise and the metric service. Is the metric service that we talked about today, is that going to be available in open source, or is that going to remain under the?
So I don't work in product, so I can't give you an authoritative answer to that question. What I can say is that for this release, it's definitely going to be a value-add feature in Puppet Enterprise. We've been talking around the office about whether that makes it into open source at some point. Just don't really know the answer to that yet, but stay tuned.
Regarding the new certificate authority, is that going to stay using the OpenSSL database style, or is it moving to Java?
PEM files still. For this, especially for this release, we wanted everything to be as backwards compatible as possible. So it actually lays down the same kind of files in exactly the same directory structure as the previous version did. And you can even still use the Ruby command line tools for manipulating certs, and it's totally compatible with how we're doing it in the server. In an upcoming release, we'll probably make some changes to that. It definitely won't be to Java key stores. Like, nobody needs to deal with that, right? And we've already figured out, we've already solved that problem. Like, we know how to convert things into Java key stores programmatically when the server starts up, so you guys shouldn't ever have to think about that at all. But we may do some things where we store the cert somewhere else besides on disk, like in a database or some kind of other persistent store, because that'll make it a lot easier for us to make this certificate authority highly available, because we won't have to worry about trying to move those files around between all the servers and stuff like that. Does that answer your question? Cool. Anybody else?
When you have multiple masters that have different feature sets, like you have the file and the input server on one side and then the loading tower on the other, how does the agent figure out what to connect to? Is that mask behind some sort of director or something?
So that diagram that I showed was sort of like forward-looking. That's not, you can't break those things up to that granularity today. When we get to that point, what you're asking is something that we definitely will be addressing. The hope is the agent won't have to know about any of that stuff. The agent will still just have one host name that it needs to check in with, and we will either have some way to do routing of the traffic once you hit the first server, or help you, or potentially farther down the road. I think we can squeeze even a lot more performance out of this stuff by having a message queue involved on the server side, so that we can have worker nodes doing the catalog compilation and stuff, and then the agent request would come into a front server, which would put that on a message queue, and then the first available worker would pick it up, and that should all be, however we end up designing that when that kind of stuff rolls out, that should all be pretty much transparent to the agent. The agent shouldn't have to be changed or have a whole bunch of extra hosts configured on it to direct its traffic to. We want to take care of that stuff on the server side. Any other questions? I only have 10 seconds, 15 seconds left, so. All right. Oh, okay. Squeeze one in.
Consider MODB as opposed to graphite whisper files?
That's a great question. We're not shipping graphite as part of the product, so you can totally set that up however you want on your end. I mean, I haven't really looked into that yet too much, to be honest. Okay, cool. That's it. I think I'm out of time. Thanks a lot. I appreciate it.